last hour. So yesterday, remember that, right? Who had to go first yesterday? Just raise your hand. Who got picked first yesterday for the notes into bell work? No one remembers? Was it you? Okay, so I apologize. Who is that? Sorry, I got to cheat. Emma, because we had a bell work question, and I said, of course, this is a difference of two squares. You saw that last year. You never saw it here, right? But then everyone did a difference of two squares correct when I got to you next. So it's our lesson today. Part of we have three factorings that we're going to tackle today. Okay, so I'm waiting. I gave this as bell work. If you're at home, pause it, do it, and then start the video again. I'm going to get going. Anyone done? How many people are done? Good factors, all right? And some people are getting fast with this. It'll be interesting to see how many people don't have check marks on their paper. Uh-oh, that means you never came up to me yesterday. So I will say this, if this factoring is tough, you got to start seeing a tutor. You got to start going to during your study hall, all right? Because some people nearly got finished with the worksheet yesterday. In my first hour, someone did finish the 14 questions because they're fast at factoring. And that's eventually where I need everyone to be at. And if you're not there, you need to do something about it, okay? So we got to get this figured out, and it's your call. Okay, so I'm kind of stalling, giving you some time. Raise your hand high if you're done. Okay, I want to see when we got about half the class. So we got about close to like 1/3, maybe a little bit more. So I'll wait about another 30 seconds. I'll use that time to check what time we get out of here. Checking the Wednesday schedule. 11:08. Actually, I have it on my computer too. Waiting. Got a new table over here. If you see, it's my prize table. I actually have to get something. I have a Boba Fett candy holder, but then I actually use it for my prize holder. I got to bring that from home. Forgot that was at home. It's awesome. You're right in this little corner here with all my stickers. Then you get to choose the stickers. You get to look at them all and see. You want a sticker, don't you? You got to earn it. Don't just get to have it. Okay. All right, enough stalling. How many people have this answer? 3, 2, 1, boom. -5 out, and then 2p plus 1, 2p minus 9. Raise your hand. All right, good. Look at all the hands that are up there. Okay, and then just for the purposes of notes, I'm just going to go ahead and show you what you could have had if you did this the long way after taking out the -5. The multiply number is -36. Lost the M up there. Let me get my pen ready. So the M number is -36. 4 times -9. A is -16. And the two numbers are -18 and 2. That's why you see the middle term split up there in that second step. Then you group, pull out a 2p. You do want to pull out this +1. You want to see the 1 so you don't lose it for your final answer. So always pull out 1 as a GCF if there isn't anything else. And then you see the 2p minus 9. How many people didn't do these middle steps? They just unfoiled. Raise your hand if you didn't do these steps. That's awesome. I think the numbers are small enough that should be the case, and we should be getting to doing that. I saw some people's worksheet yesterday. That's why I'm glad I did what I did. And for x squared plus or minus a number, they're using 4 steps, and that can't happen. You've got to get fast with factoring. Today, this is going to be a memorization day. You're going to have to look at it, recognize it, answer. No work. All right, and that's actually a good thing. Efficiency. And here it is. We're jumping right into it. And there's what I mean. I feel so bad. And you can call this 2-7. It is 2-7. 2 things. And actually, you don't even need this one. You could survive without it. But this is an extra file to speed up your life. I'm telling you. Because this could simply be just an MA. It's a trinomial, and I factor it, but it ends up being a binomial times itself. So therefore, I often call this a trinomial square, or a perfect square trinomial. So here's the formula for it. Now for you, hopefully when you get a complicated question, oh, wait a minute, I recognize this as a trinomial square, I can factor this faster. And I'll show you that when we actually have an example of it. And they show some small ones here. It's more important when they're bigger numbers. So But this is the format that it takes. Just go ahead and write that down. And then look at the factoring of a difference of two squares, which I unfortunately forced on you yesterday and I forgot. I thought we covered it because I was thinking of my cat cross-reference with you. It was like a cross-wiring. But a difference of two squares is very easy. It's two terms. That's why it sticks out like a sore thumb. It's not three terms. It's not a trinomial. There's a minus sign, difference, and then these two are perfect squares. So automatically, they will factor to perfect square plus perfect square minus perfect square. Why? Good foiler, say it. Look at b times negative b. Does that end up being negative b squared, right? And then look at the middle term. What happens to the middle term? It starts with a C. 3, 2, 1. Cancel. Only one person said it out there. Cancels. So this is easy, and we actually did this yesterday because of my accident. And you guys all did awesome on it. After I made you go first, then everyone else factored a difference of two squares correctly in 2, 3, and 4. Right? You remember that? Who went in the bell work yesterday had to do a difference of two squares? Nobody remembers one day to the next. No one's raising their hand. Alrighty then. What did I tell you? There's three things today. This is one. This is two. The third one is going to be complicated. This is what I don't accept, though. You ready for me to be mean? I don't accept. I don't get it. I just don't get what he did today. No, there is memorization. You didn't memorize. It's not that you don't get it. You didn't memorize, because this is a formula coming at you. Here is the last thing. Oh, I'm sorry. Let me show some examples of perfect square trinomials and why difference of two squares works. This one, I don't think you would need to know that this is a perfect square trinomial. Because what multiplies to 64 and adds to 16? What's the answer to that? 8 and 8. So right off the bat, you do this. You just do x plus 8, x plus 8. Oh, okay. This is a binomial squared. So this is a perfect square trinomial, and I can write that as x plus 8 squared. Right? I'll show you where this really comes into play in our first example of the day when this happens. Then, of course, what multiplies to 64 and adds to negative 16, because they were too simplistic in their example, it's negative 8 and negative 8. So this is x minus 8, x minus 8, which can be written as x minus 8 squared. So write one of the two. I don't really think you need to write that as an example. I have a mishmash of factoring questions at the end. Those are our examples. Those are our honors examples. Then over here, I'm sure you can see, I don't want to confuse you by looking at it, but this is identifying, look, I have a difference of two perfect squares. Look at how it factors. Good foiler, say it. Look at the middle term. They what? Starts with a C. Cancels, and then what's 6 times negative 6? Negative 36. That's why it's plus minus. All right, so this all fits with the good foilers, good factors idea. That's why this is an easy thing to remember. Then that second example is just kind of silly. Take out a GCF, and then you have the exact same thing. X minus 6, x plus 6. So I wouldn't even write this one. We know how to do a GCF. You know, you take your notes what you think you need. Don't know if you actually need any of these. Okay, now here's the thing. This is the third thing. And then I'm actually going to do difference of cubes above it. But write the sum of cubes. And this is what I mean, but boy, I just don't get it. There's nothing to get. You got to memorize this pattern. Okay, and that's what it is. So now the third thing that has a specific pattern in factoring, this is special. This one you need to spend some time on locking this formula in. Sum of two perfect cubes. Okay. Look at the first set of parentheses. And the book is awesome. I'm not going to let you write down what I'm going to show you next, but I'm going to prove this. And the book does it. So I'm not going to do it. I'm going to show you what the book does to prove this. All right, but here's what it is, and this is what you want to take formally for your notes, and then focus on this to do your homework. It's a binomial times a trinomial, because it works, it's true. And then look at the first binomial. Perfect cube of A and the perfect cube of B. That's what goes in that binomial. Got it? You see it? Then the trinomial. notice, and I'm going to write this since I'm making a movie here, this term is that term squared. So I focus on the binomial, go to the trinomial, and I point at this and say, all right, this squared goes right here. That's the beginning of the trinomial. Then this middle term is these two multiplied together, a times b. And then the last term of the trinomial is whatever this is squared, right? So once I get the binomial, I focus on that to fill in the trinomial, right? And that's the pattern. And now you're going to ask yourself, what about the signs? Hey, put this above, because we're going to use this acronym for a difference of two cubes. Sorry, not there, not there, not there. So, what do you think S stands for? And in class, I'm going to point at this and then look at that. What do you think the letter S stands for? What word? It's an acronym. S stands for a word. Sign, but what is the sign here and here? They are the same. They're the same. The signs are the same as we start. That was a sum of two cubes. And look, this is the same as that, right? So what do you think O stands for? Come on, everybody. Now what did the sign do from the beginning? It's the opposite. And then what do you think this stands for? Always positive. All right, so go ahead and write those things down because now we're going to do the difference of two cubes, which actually does factor correctly. Or does factor. What did I say? 08? Is it 1108 today? All right, so memorization. Okay, so now difference of two cubes is almost identical to what we see below. So what do you think you have in your first set of parentheses? It's A minus B, not A plus B. The perfect cube of A, A cubed, and the perfect cube of B cubed. A and B. Okay, everyone, tell me what's here then. What's the next thing? 3, 2, 1. A squared. Okay, and then what's the sign? 3, 2, 1. Plus, because it's the opposite of minus. So those just flip-flop. Okay, then everyone in the middle term. 3, 2, 1. What is it? AB still. So that's why these are identical. You just got to get your signs. Always positive, plus, and then 3, 2, 1. What's the last term? B squared. And now we're going to go through a proof that these work. But square these, you know that this is our formula for sum and difference of cubes. And then you could go away from this one, but definitely this is for sum and difference of two squares. By the way, right next to sum and difference of two squares, write this. A squared plus B squared, not factorable. It doesn't factor. Some people might think it's, well, wouldn't it be A plus B times A plus B? You know what A plus B times A plus B has? Starts with an M and a T. 2 words, MT. A middle term. This is not true. This does not factor to be that because it doesn't FOIL to be that. That's why that's unfactorable. So do make a note to self on that one. Okay, do not write this down because we do not have time, but just accept. So this book is awesome. They prove that this actually works. This is using the distributive property. I just like doing the lines, right? If I multiply this to get this, then this factors to be that. This is what I did on the board. If this multiplies to be this, then this factors to be that, correct? That's the whole relationship I've been talking about with factoring for the whole time that we've been here. So now look at this. Don't you agree that this is A cubed minus A squared B plus AB squared plus A squared B minus AB squared plus B cubed. And now look at the like terms. Cancel, cancel. Cancel, cancel. I don't even need that, but they're just showing that those are like terms. And lo and behold, I get this when I multiply. So when I go in reverse and factor, that's what I get for an answer. Everyone with me? Otherwise, you're against me. All right? And then when you look at the difference of two cubes, notice a times a cubed, a times a squared b, ab squared, distribute the negative. Negative a squared b, negative ab squared, negative b cubed. Cancel, 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 cancel. I end up with this. If I multiply to get this, then this factors to be that. There's the proof. Got it? Okay, now it's memorization. There is no I don't get it. There's memorization. Okay, so now we're gonna jump. I think what I put one together. So let's just make up one. Let's make up one like 27x cubed, and let's do a sum. And then let's do another popular one is 8y cubed. I did a little different than the other hour. The other hour I did something simpler, like I think just plus 1 maybe. You know, 1's a perfect cube. 1 times 1 times 1, right, everybody? Okay, so now factoring this, and is it true? Good FOILers are good factors, so you'll prove that. And I should call on someone, but we don't have the time today. So everyone, in 3 seconds, what's the perfect cube of this first one? 3, 2, 1, go. 3 what though? 3x. 3x times 3x times 3x does equal 27x cubed. So there's the perfect cube of 27x cubed. All right, 3, 2, 1. What's the second perfect cube? 3, 2, 1. 2y. And then feel free to put this up at the top. Same, opposite, always positive. That's just for the signs. And then that implies that you have a trinomial in the second part. So same as plus, and if you want to do this, then get the signs in there. There you go. So now you have your positions ready, right? So do the same, opposite, always positive, and then you know you have a binomial times a trinomial. Okay, now here's where students go wrong. The first position is this squared, 3x squared. But a lot of people just square the x and not the 3. Good FOILers, say it. Because this drives me nuts. What is 3x times 3x squared? 9x cubed. Is that correct? Yes or no? No. So we square the 3 as well. This is supposed to be 9x squared here. Square the 3 and the x. Now, does that fit? Good FOILers, good factors. Yes? This is what drives me nuts. People write nonsensical answers that don't FOIL to be the question. So make sure you don't do that. These two multiply together. 3 times 2 is 6 xy. And then here's the other thing. This squared is not 2y squared, it's 4y squared. And minimally check this. Does that check out and give me the last term, yes or no? Now if you have the time, check everything else. Does it cancel? So 3x times negative 6xy, that's negative 18x squared y. I'm just going to verbalize it. And then this is positive 18x squared y. Good. And then this next one is 12xy squared. This is negative 12xy squared. I'm good. I'm a good FOILer, therefore I'm a good factor. I check these things. All right, and then turn this into a circle. That's the final answer. There is no I don't get it. It just is. Okay, so now, today, there's only these 3 types on the worksheet. No time to ask everybody these questions, so it's going to be a 3, 2, 1 again. And this is not, you have to write this down if you wanted to take notes. Okay, is there a GCF? Just yes or no? 3, 2, 1, go. Yes. What is it? 3, 2, 1. Ooh, not 6. Ooh, did you hear all those numbers? 6, 4, 2, hike. All right. It's, I think it's 4, right? And then now you're going to have to really focus. This one isn't too bad, though. What do we have of our three things? Is it a perfect square trinomial? It's not even a trinomial, guys. Is it a difference of two squares or two cubes? Which one is it? Difference of two squares. Right off the bat, it should be just the answer. What's the perfect square of 4x squared? 2x, 2x. What's the perfect square of 9? 3 and 3. Two reasons why it's got to be plus minus. Number one, it's a negative 9. Good FOILers, good factors. Number two, what happens to the middle term? 3, 2, 1, go. Cancels. All right? That's why it's plus minus. It's just because it works. There is no I don't get it. There is memorization and recognition. Recognition of the type of question I have, and then what do I do about it? Kind of thing. Okay, I'll breathe a second because people are finishing writing this. Everyone okay so far? All right, look at the next one. I think these I focus on just those. I love this one. This is really where the trinomial square thing is going to be helpful. Because first of all, the m number is quite large. What is 25 times 16? Anyone know? Because it is and could be an MA. We could think about, all right, I got to do this long process. I got it. We have no time for this. You should have your calculators ready. And then what's the A number? 40. Hey, what are the two numbers? And by the way, 400 is a perfect square. What times 1 equals 400? What? 20 and 20. With that being the case, this actually is a perfect square trinomial then. Just check. Question, is this true then? Is this true that I have a perfect square as the first term, a perfect square in the last term? Do I get the middle term if I make this 5b and 5b and this plus 4 and plus 4? Why is it both plus 4 and plus 4? By golly, it's positive 16 as the last term. And the middle term is positive. Does this work? Yes or no? Yes. So this is a perfect square trinomial. If you can hold that as a folder, as a separate folder, then it will make factoring faster, and you don't have to do the 4-step process then. You with me on that, or yes? Yes or no? You get it? Otherwise, you can. You can go ahead and take 4 steps on this. You just might run out of time on my test. Just saying. That's those that are doing those 4 steps on all questions. You're not going to make it. All right? It's not going to, you're not going to finish. So we got to get efficient so that we can use factoring to do other complicated things. That's going to happen later. 11:08, right? Okay, I'm just assessing my time. By the way, you have a choice to write it like that. You could leave it like that as well. You don't have to. It's not mandatory, is what I'm saying. All right, because I know sometimes you worry about that. Oh, baby, look at this one. Woo! First of all, look, someone even just threw something on the floor. I'm so frustrated with this question. Just kidding. Is there a GCF? 3, 2, 1. What is it? 3, 2, 1. It is 4. Okay, now this gets a little crazy because you know what? X to the 6th is a perfect square, but it's also a perfect cube. What times what equals x to the 6th? X to the 2nd. What times what equals x to the 6th? X to the 3rd. But then when I pull out that 4, what's 16? A perfect square or a perfect cube? This is a difference of two squares. X cubed and x cubed does equal x to the 6th when multiplying, minus 4y cubed plus 4y cubed because I have a minus, and then that does equal negative 64. And then yet again, what happens to the middle term? Cancels. So that is the true factorization of this. And then we move on. So bigger variables, you just got to think of cubes and squares with variables and exponents and knowing how the exponents work. Can I move on? 3, 2, 1, next one. Hi-yo! First of all, is there a greatest common factor? Ooh, 3, 2, 1, go. I got a yes and a no, and that happened last hour. I got a question for you. What's 7 plus 5? What? What's 7 plus 5? 12. Does 3 go into 12? 3 goes into 75. What's 6 plus 0? 6. 3 goes into 6, 3 goes into 60. And 3 definitely goes into 12. So definitely a 3 comes out. And now you could do a tough MA, but you know what? The first term is a perfect square, and the last term is a perfect square. This may very well be a perfect square trinomial. Let's test and see if it is. Good foilers, say it. We'll see, does 5u to the third here and 2v to the third here positive middle terms, so these both got to be plus for two reasons. First of all, that does equal positive 4v to the sixth. Second of all, do I get the middle term appropriately by doing this and that? Yes or no? Then it works. It's no longer a question mark. That's how we can do a perfect square trinomial faster. We can test, does that work? And if it does, then we're good. Yes? Oh, you're right. Oh my goodness. That's a 20. My bad, dogs. So yeah, that's 20, and that's important because this is 10 u cubed v cubed. This is 10 u cubed v cubed. My bad. All right, so good. I forgot. Someone caught me on not taking out that 3 from the middle term. Whoopsie daisies. Okay, and anyway, you could write this as 3 times 5u cubed plus 2v cubed and just this squared. You could. You don't have to. This is a valid answer, and you could rewrite it like that. Either one is acceptable. I don't want you to think you have to do that. All right, so I'm going a little faster than the other hour. We will be able to do like a few more. I only have 2. Well, I do have 4 things here, but I think that's too easy. Let's go to this one. Do I have a GCF 321? Yes, and it's simple. It's a 2. Now, what did I tell you about 1? 1 is a perfect square, but it's also a perfect cube. And then, okay, apparently I love 27 as a number. I think I used that before as a perfect cube. So this is a sum of 2 cubes. So now here's the pattern, and you do have to keep this in order. The perfect cube of 1 is 1. The perfect cube of 27 yet again is 3, but in this case 3a. 3a times 3a times 3a. Same, opposite, always positive. I'm going to slide this over so I give myself room for this trinomial here. Same, opposite, always positive. I kind of like doing that. I like getting the signs over with. Then I know I have my positions to fill in. 1 cubed is 1. By the way, what's 1 times 1, everybody? Good. And then 1 times 3a is 3a in the middle. And then here's the kicker. What does that have to be? Well, it's 3a squared, which is 3 squared and a squared. Does that equal the last term? Yes or no? Yes. What's going to happen to everything else? It's going to cancel. If you have time to check it, check it. If not, move on. But that's what makes me sad when we do a sum or difference of 2 cubes that one of these don't fit. Like this is wrong. This times this doesn't equal that. I don't know why you're writing that as a final answer then. You have done nothing about good foiling, good factoring, what I've been saying all year long. Let's do this one real quick because I think this is going to be our biggest problem. And then I'll end with the one previous to that. Okay, so just don't call it 14. I pulled this from like some sort of thing I developed. Holy cow. First of all, is there a GCF? 3, 2, 1, go. You should at least say yes because they're both even. So it at least goes into both of these. 2. I mean, that should be instantaneous. All right, I don't know if anything else goes in. So I'm going to take out the 2 and see what's left over. Oh, and then what else? Variable-wise, what else comes out? 2v. Okay, so I get 64. 64 is a perfect square, but it's also a perfect what, everybody? Cube. Oh, and then I have a sum. I bet you this is going to be a sum of 2 cubes. 2 times 125. Oh, yeah. And then v cubed. Look at the variables. They give it away that we're trying the cubes thing. By the way, what times what equals 125? And 3, 2, 1, go. 5. 5 times 5 times 5. So don't forget the 2v. Again, this is for teaching purposes. I don't get to get a student here today in our shortened time. Perfect cube of 64 is 4, not the perfect square. 4 times 4 times 4 is 64. And then 4u. Perfect cube of 125 is 5, and then v cubed 5v. And then notice how and then I did it. I already did the same opposite, always positive. I'll do that next. Notice how I do this. I check my answer at least first and last. So what goes here? This squared. People often don't square the 4. Well, I'm going to square the 4 and square the u, and then ask you, is this times this equal to 64u cubed? Yes or no? Then it checks, and I know I'm okay so far. Multiply those two together, you get 4 times 5, which is 20, and then it'd be smart to do uv, right, in alphabetical order. And then at the end, square the 5 and the v. And I forgot to say this. Notice that we get a binomial times a trinomial, and some of you might have been thinking, wait a minute, trinomials can factor through MA. It never happens in a difference of, or sum of 2 cubes. This is always unfactorable there. Did you hear what I said there? This is almost always. I think I found one special case one time in my life and I searched for it. But that is almost always unfactorable, and you can really count on it. So don't try to factor that further. You got me? All right. But then again, check, does this at least satisfy the last part? Does it or doesn't it? Yes, 5 times 20. Oh, I lost my 25, sorry. When I erased, I lost the 20. 5 times 25 is 125. V times v squared, v cubed. And then if you have time, check the middle stuff. Okay, what did I say I wanted to do? Maybe not that one. I think that's, let's do this one. Is there a GCF? And what should I pull out, a positive or a negative? Negative. And so it's negative, I think it's 6. And then you end up with K. This isn't any of those. I think I might have thrown just to minus 5K plus 6. Yeah, this is just a simple. Are those any of those perfect squares? No. All right, so I don't even know if this is factorable. Did I pull this out correctly? Oh, this is a positive, right? Oh, then this is a negative. Whoa, boy, oh boy. I'm screwing up all over the place, all right, with my pulling these out. So actually, this is going to be an unfoil or an MAer. This is factorable if this is, I can satisfy that. Are there two numbers that multiply to negative 36 and add to 5? Which one, what are they? What and what? 9 and negative 4. So if you wanted to do the 4-step process, go for it on that one. So this was neither of these. On your worksheet, this doesn't happen. All of them are either a difference of 2 squares, the cubes thing, or perfect square trinomials. Notice what I did there. I made that plus a negative. I'll change colors to pull out GCFs. I should really use brackets, but it's too late. All right, then you can go. I'll use brackets. I'll pull out a 2K. If you wanted to keep looking, this is 3K plus. Wait a minute, that's a 3K. I'm messing up all over the place. And then you pull out a 3K out of this. This is 3. Is anyone listening anymore? And then pull out a negative. Have a good day. Hey, thank you. I knew I was going to get that from you. And that's a 2K. I'm screwing up again. 2K plus 3. And then this is negative 6K as nobody listens. 2K plus 3. Hey, you two, take it easy. Hey, you two, take it easy. 3K. Hey, you two, take it easy. Very polite second hour. Nice. All right, done. And then you're still here?